We're doing binomial distributions, which I hope that you think it's a little more straightforward than lesson 12. In lesson 12, we were thinking about things in a little bit of in a weird way, and it's new and it's strange, and so that kind of makes it a little bit confusing and a little bit difficult. But starting in this lesson 13, we're going to be using the calculator to figure out all these statistics, 100% on the calculator. Really, it's kind of plug and play. So let's look at the worksheet. Again, we're doing binomial distributions, which is 2 options only. Yes, no, I have pets, I don't have pets, true or false, Democrat, Republican, I voted or didn't voted, right? Only 2 options in this binomial distribution. And so we're using our calculators. And our calculators is second FARS, and that's where we're going to live for pretty much the rest of the semester. And we're looking at Binom PDF. But remember, if you have an older calculator, it might not be A, it might be 0. All we're doing is we're putting in the number of trials, the probability of success of those trials, and then the number of successes that we're interested in. Let's look at an example. It'll make a little more sense. Look at number 2. A packet of seeds has a germination rate of 92%, and this means the probability of any seed sprouting is 0.92. So that tells us there's the p-value that we're going to put into the calculator. So before we go on with this, we want to know how many seedlings we expect to germinate in a row of 50 seeds. So it's a row of 50 seeds, so that tells us n equals 50. And this right here is asking for the expected value. And remember, with the binomial distribution, they either sprout or they don't sprout. It's 2 options, which is why this is binomial. And the expected value is just the number of things times the probability of that happening. Basically, what we're finding is 92% of 50. That's why it's a product, because they either germinate or they don't. Okay, 92% of 50, there's your n times p. So we expect 46 seeds to sprout. Okay, and remember that 92, in order to do the math, it's 0.92 times 50. Okay, now let's move on to the calculator portion. So we want to know what's the probability that 50 will sprout. So this is 50. It's not saying it, but what it means is exactly 50 will sprout. So what I'm trying to find is the probability that x equals 50. Okay, so I want to find the probability that all 50 sprout. So I'm going to put that 50 here. That's the x. That's this 50. But the other 2 come from above. N is 50 and p is 0.92. Okay, and I'm just going to fill in all the calculator bits first, and then we'll go do the calculator, and I'll show you what that looks like to make sure everyone's on the same page. Okay, and then again, on these next 2, because we're still talking about that row of 50 seeds with a 92% germination rate, this information is the same for all these other ones. N is still 50, P is 0.92. N is 50, P is 0.92. Okay, the only thing that's changing in each of these scenarios is this X value. In part C, I want to know the probability of exactly 50 sprouting. In part D, it's exactly 48. So X is 48. Okay, so then I'm going to put, here's a 49 and here's a 48. Okay, and let's see what that looks like on the calculator. We're using second VARs, and you can remember it's second VARs because that says distribution above. Okay, we're going to arrow up to A or 0, and you see it says Binom PDF. We're going to press enter. Okay, if you don't have this on your screen, if you don't get the menu, if you just get Binom PDF put on your screen, you're going to enter the same values, but you're going to insert a comma between these values, and the comma is right above the 7 button here. So the number of trials again is 50. The probability of success is 0.92, and the X value we're interested in is 50. Okay, so now I'm going to press enter. Enter. Those of you that didn't have that menu we were just looking at, your screen should look like this, yeah? If you get an error ever, double check that you have a decimal place. Sometimes decimal doesn't press all the way. Okay, so we're going to press enter, and there's our probability. So the probability of all 50 germinating is 0.015. 1.5% chance that all 50 will sprout. That's a pretty slim chance. Now we want to do the same thing for 49 and 48, but remember that we can use second enter, and that will bring back the last thing we entered. So then we can just use our arrow, an arrow over the 50, and it'll just write over it and change it to a 49 and press enter. So 49 out of 50 germinating is a 0.067 or a 6.7% chance. Okay, and then we're going second enter again, change that 49 to a 48 and 0.143. You see how much easier that is to use that second enter than having to go and re-enter everything every single time? Okay, that's going to save you a ton of time. Go back to the worksheet then. Okay, so now I want to know the probability of either 48, 49, or 50. And remember, we have two different formulas, but we're going to use the addition rules of probability. And remember, those are in lesson 10 and 11, actually. Okay, and these are mutually exclusive, so all we have to do is just add them up. So we take these three probabilities and we add them up. So 0.015 plus 0.067 plus 0.143, and you should get a 225. This, would you agree, is a bit of a pain doing all of this, especially if I just asked you finding this probability here of either 48, 49, or 50, and we hadn't just computed it. You don't want to have to go and compute each one of those individually in order to find that probability. And so that's what we're going to be learning today, is how to find what's called a cumulative probability. And cumulative probability just means a probability of more than one thing occurring at the same time. So the probability of fewer than 48 will sprout. We're going to use that complement. What's nice is this is a binomial, so they're discrete. So we just found the probability of 48, 49, or 50, which is those three. Here I have 50 green dots representing each of the germination rates of all 50 seeds. We just found the purple bit. What we want to find now in F is the probability of any of these sprouting. So that's the remaining 47. Okay, so we want to find the probability of strictly less than 48. See, it says fewer than 48, so that doesn't include 48. It's talking about less than 48, which really means the probability of 47. Okay, so what that means, we can say 47 or fewer. And that nuance in the wording is going to be really important for what we're going to do next. And we know that it's a complement, so it's 1 minus 0.225, which is 0.775. Remember, complement, another way you can think about that is this is 100% minus 22.5%, which is 77.5%. So let's fast forward then. And so we have two types of binomial distributions. So what we were just doing is the binom PDF. And that binom PDF is for when you have exactly a certain number of successes. But like I said, where we're going and what we want to do is we want to find an easy way to find a probability of a number of successes happening. Okay, and that's what we're going to use, that binom CDF, which you probably notice is that function right below the PDF. And that C stands for cumulative probability. We use it to find the probability of less than a certain number of successes. What you want to look for is words like at most X successes, less than a certain number of successes. When we do an example, this will make a little more sense. So example 1 illustrates the differences between the cumulative and the exact success. So here I have graphs of a histogram showing a binomial distribution with 6 trials, and P is 0.25. So I want to find the probability of exactly 2 successes. I'm looking at just the probability of that one bar there. Okay, and that's similar to what we were doing in the discrete probabilities in the beginning of lesson 12. I'm finding the probability or the height of just that one bar. But if I want to know the probability of 2 or fewer successes, that is the cumulative probability of these 3. And we say cumulative because what we're really doing is we're finding the probability of 0 successes plus the probability of 1 success plus the probability of 2 successes, just like we did in that last example. Okay, but the nice thing is, in the last example, we had to find those 3 probabilities individually and add them all up. The calculator does that for us when we're using the cumulative probability. So it's doing all that math for us and just spitting out that sum. And so notice we're doing 2 or fewer. So what is here is the 2. This number is included in the calculations, and that is really important to remember. And that's important to remember because I could ask you for less than 3, just like we saw in that last example. Now notice less than 3, I don't want the 3 included. I just want less than 3. I only want 0, 1, or 2. So I don't want to put the 3 in here because that will include this 3 as well. Okay, so the one thing you're going to have to be conscious of and ask yourself every single time is is the number that I'm asked to find the probability of included in this or not? And remember, it's discrete. So if it's not 3, the next one down is 2. Also notice,
I have a
sorry.
quick question.
Yep.
I was wondering if the successes could ever be like not a whole number.
No, not for this. Because here we have discrete variables, and that's a really important distinction. And that's why the answer is no. If we had a continuous variable like height or weight, then the answer would be yes, right? Because you can weigh 14.5 pounds, but you can't have 14.5 people, right? So here, doing this discrete probability, we're looking at basically people. But what we're going to start in the next lesson, we're going to be looking at the weights, the continuous probability.
Gotcha.
Okay.
Thanks.
Okay, yep, it's a good question. So one more thing I want to make sure you understand about this cumulative probability is that notice this function that we're using in our graphing calculator starts at 0 and goes to the number here. So when I put that 2 here, what that means is the calculations from 0 up until whatever number is here. And that's why it's so important that we consider if the 3 is included, but also notice these are all less than. It's 2 or fewer, at most 2. So those all mean 0, 1, or 2. So if we want to find more than 2, if we wanted to find the remaining bits, if we wanted to find this bit here from 4, 5, or 6, 3, 4, 5, or 6, this is when we would have to use the complement, okay? Because the calculator only knows how to start from 0 and fill in to the right. It's the only way it knows how to do things. Okay, that makes sense? Okay, so let's do an example, and then I'll put you off on your own. I'm going to do example 3. I'm going to skip example 2, because example 3 is kind of a mix. Okay, so here's just kind of a tip for you. If it's exact, if you're asked to find exactly one number, we're going to use the binom PDF. Okay, if it's less than a number, that means we're using the cumulative probability and it's binom CDF. If it's more than, we have to use the cumulative but the complement. So we're going to do 1 minus the binom CDF, okay? Because again, the calculator only goes from 0 up to a number. It can't go above a number, okay? So for each of these, we have to ask ourselves, is it PDF or is it CDF? That's the first thing you want to ask yourself. The second thing you want to ask yourself is the number I'm told included? When it's written like this, or when it's written like this, is 15 included? Here, is 12 included? Okay, same question for number 10. Is 12 included? Okay, and then for 11, we want to know, is 13 included? Okay, because that tells us what we're going to be doing. Okay, so in number 6, hopefully you see this is an exact. So we're going to use PDF because it's exactly 15. Okay, when I should back up, step 0. I forgot to include step 0, folks. Step 0 is figuring out your N and your P. Can you see here I have a binomial experiment with 24 trials with a probability of success for each trial equal to 0.67. So what I do is I always write over here, because I'm going to be using it many times, I write N equals 24 and P equals 0.67. Okay, so for 6, what I'm looking at is binom PDF because it's an individual one. And remember, it's NPX. So 24.67 and X is 15. Okay, does everyone see how I came up with that? I'm just going to come up with the functions and because I want you to work on these on your own. So I'm going to skip the calculator part for now. Okay, so for this next one, hopefully you see this is a less than, which means it's a CDF. So it's a binom CDF. And is the 15 included? Yes, because you see it's got that or equal to. Okay, so my binom CDF is 24.67 and 15 again. Do you see how they look exactly the same? Do you see that the only difference is the P versus the C? Okay, that's not a coincidence. It's just like we did up above, exactly 15 versus 15 and below. Okay, so the complement, part 8, the complement of P is less than or equal to 15 is P is greater than or equal to 15. Okay, so in this one, we don't have to worry so much about if 15 is included for here. We need to know about for this because this is the less than. So this is what we would use the binom PDF for, binom CDF. Okay, and that would be 24.6715 like we just did, but we want everything else. So this is where we're going to do the 1 minus because we want to find what's above 15. And what's above 15 is actually, P is probability that X is greater than or equal to 16. Okay, so what we just did here, you can think about it this way. In the above one, the 1 through 15, we found these. Okay, but we're now asked to find what's bigger than 15. So we're finding the remaining parts. So that's where we use the complement. Okay, and number 9, we're looking at 12 or fewer. Is 12 included? Yes. Again, the same thing we did up in 7, except instead of 15, we are looking at 12. So it's still 24.6712. So you see how that second enter is going to come in really handy?
Would it be binom CDF in this case?
Yes. Oh, thank you. You're absolutely correct. CDF. So then what's the probability of more than 12 successes? So more than 12, 12 is not included. We're looking at 13 and above, which means what we put in our calculator is going to be the complement of the binom CDF for 12. So 24.67 and 12. And I'm sorry, I've kind of run out of room there. Okay, so we're going to do 1 minus this.
For number 9, like, would there be a difference if there was 12 or fewer, or if it was just less than 12?
Yes, less than 12 does not include 12. So if it said less than 12 means 11 or fewer, because again, discrete variables. So there is no 11.9. Similarly, just like here, more than 12 means 13 or above. But at least 13 means 13 or above. So that's why I was saying you have to be careful with the wording, okay? And if you flip back up to example 1, these all mean 0, 1, or 2. 2 or fewer, at most 2, or less than 3. What I'm going to have you do then is work on example 4. And again, be careful with the wording, okay? And ask yourself, binom PDF or CDF? And if it's a CDF, is that value you're given included or not? Or is it going to be a complement? Okay, welcome back. Before we leave, I want to show you something about 13A. 13A, that's an exact probability. So we're doing binom PDF. So we're doing second vars, binom PDF, and we have 5 trials, 0.25 probability of success, and we want to find the probability of exactly 5 correct. And you see I get this number here. Remember, anytime you get a value other than 0 before the decimal place, you need to ask yourself what's going on. One of 2 things are happening. Either you've made a mistake or you keep reading and there's this E here. Remember, this E -4 is scientific notation. That means the decimal needs to move to the left 4 times. So what number this really is 0.00097656625. Okay, so this is what number it really means. Now in statistics, we can't get this level of accuracy. So when you see this E, remember this is when we say the probability is effectively 0. And that's how I remember what the E stands for, effectively 0. So the answer here isn't the 9.76, it's the effectively 0. And I guarantee you on the answers on one of the test or quiz questions, and maybe the homework as well, is going to give you this as one of the options. If this question were on a test, one of the options would be 9.765 or 766. Okay, so don't fall into my trap. It's really just a test to make sure you're paying attention that you should know no probability can ever be bigger than 0. So the effectively 0 means it's not guaranteed to not happen, because that's what 0 means, but it's so close to impossible that it's almost impossible. All right, so I guess that's it then. So have a great afternoon, everybody. Thank you.